Hey, it's been a while since I've posted a video, but in this video, I'm going to show this visualization tool I made. So basically, it has to do with quaternions, and so we have a starting position, which is a bunch of quaternions, basically in a 4D, actually no, in a 3D grid. So the W is unchanging, and the X, Y, Z are basically changing as you would expect the grid. Like if you look at two adjacent points, they only differ by one direction, I guess, like. And then what it does is it applies a function, in this case it's q squared, on each of these points, and then graphs all the whole set of points resulting from that operation. So here, let's say we have at the corner this point 0.5111. It becomes negative 2.75111, or 111, which is what you get when you square that point. And well, the color is basically the W, and then the X, Y, Z are what you would expect. They're the position in 3D space. So that's how it's graphing the quaternions since they're 4D. And so you can mess around with the function. Q squared doesn't actually change the shape, but if you do Q cubed, for example, you get a different shape. As you can see, you can also hover over points to see what they are. And you can zoom in, zoom out. Now, a nice feature is you can show lines, which it's convenient. You get to see more stuff. You can also mess around with the point density, just how many points you have. The input W value, now, since we're starting with a grid with a fixed W value, you can just change that around, and you get different behavior for some functions. In this case, if you go negative, for example, you can get like a cube shape, which is interesting. And then there's some more operations, so you can raise it to an integer power. It doesn't support fractions currently. You can normalize it. You can take the conjugate. So let's multiply with its, or yeah, for example, let's multiply the quaternion by its x component, and we get this cool, almost parabola looking thing, but 3D. And there's a lot of different interesting graphs you can make from this. And there's also a setting where instead of lines, you can show faces, which is, well, I think this graph makes overlapping points, so it might not work for this one, but if we try some other graphs, oh, we can get a clean looking shape, especially if we make points smaller, so we just see a shape. Let's do 1 over q, for example. It's a cool example. As we drag the W around, we get interesting graphs, and there's actually points around too, so if we increase the point size, we can see the clusters of points. And then there's also more you can do. So basically, right now we're starting with a fixed W value and X, Y, Z in a grid, but you can also do a plane. So that's just X, Y. Let me make points larger. The X and Y are changing, and the Z and W are fixed, as you can see. And so it's just the same thing, but it's applying on only those points that you start with. So you can also do a sphere, which is, you also, so you do like Q plus Q, sort of becomes like a skewed shape, skewed sphere. And you can do more shapes, so you can do the edges of a cube, you can do the faces of a cube, and you can do a torus, which is interesting. And yeah, for all of these, you can change the point density to whatever you want. And finally, you can do a 4D grid, which, to explain what this is, essentially, like, on each point you see, there's actually multiple points. So it's on this point where we see negative 1, 1, 1, 1. There's points with W values ranging all the way from negative 1 to 1 on that point. So if our point density is 10 in a 40 grid, we have 10,000 points. So you need to be careful with the point density. But once you actually apply a function, the graph can get separated out. So let's do something like q plus q times plus j plus k plus 1. And see what we get. We get this cool, I'm not sure what it's called. Maybe like a rhombic icosahedron or something. I don't know. But you can do faces if you want to see the... Well, faces don't work for 40 grids, but they work for all the other shapes. Like a tortoise, for example. And yeah, so there's a lot of interesting stuff you can mess around with here. And then some example stuff here. And yeah, I'll post a link to this in the description so you guys can try it out. And if you have any suggestions or whatever, you can post it in the comments.